different number of rows. And then so just a second. So what is the error? Okay, so we can do one thing. We'll just copy the path from here, and I guess this should work. Yes. So this says that we have 414 rows and 8 columns. So we can take a look at the data by seeing the head and the tail, right? The top 5 and the bottom 5 rows. So data dot tail. So this is what the CSV file is. We get a small overview of it. To get the summary of the CSV file, we can just put csdata.info. So we have like what type of column. So there is no null. That's a good thing. And we get data types. So we can just, to be sure, we can check the pair plotting and pair plot of the data file. So in this, like each variable will be mapped to each other variable. So this is what pair plot should look like. Give it a second. Okay, so this is how our pair plotting would look like. So every variable is mapped to every other variable, as we can see. Now, since we have to predict the prices based on other factors, we will drop the column where prices are set, that is the Y column. So we'll use data dot drop, and column name is Y house price unit area. Just copy it from here, just paste it here. So, and we have to remove it from axis to one, so sort of mention, and then we will set Y to the data, to the house price unit area. So we can set it as data, and this. So this should work. So we'll just check what are X and Y now. Okay, so as you can see, X is everything from the CSV file except the Y column, and we can check what is now in the Y column, like the Y variable. So all the data related to Y column is now here. So for like the further things, we will import test and split from scikit-learn. So sklearn dot model selection import train test split, and yes, and then we can set the variables as underscore train comma x underscore test comma y underscore train comma y underscore test, and then simply assigning the function train test split. Now we have to split y, x and y. So for testing purposes, we can set the test size to say 30%. So we can, by default it is usually 25%, but For change, we can set to whatever value we want, and we'll just set the random state to 0. And I hope this no error. Now we will import the linear regression model from scikit-learn. So from sklearn dot linear model import linear regression, and then we will assign a variable called model to linear regression function, and then model dot fit x underscore train comma y underscore train. So this is so okay. This has worked. Now we can check the data frame. PD dot data frame of coefficients of model we have got. Model dot coef underscore comma x dot columns comma columns equal to we can set this to say coefficient, and this should work. Yes, so we have now got like the number as this coefficient from the model, linear regression model, so it computes on itself. And then now we can predict using the model dot predict x underscore test data. So we'll predict y predict obviously from the test data we want, and then we will again do framing data frame. We'll just set this labeling. Just a second, okay? This should go like this: y underscore test, comma y underscore red. This go y underscore prediction. This should work. Yes. So here we can compare prediction data as well as test data. So y value obtained from test versus y value obtained from predictions from the training data. This is from training data and this is from testing data. And now we can similarly check the like say top 5 columns, but if we want to, then we'll just copy this. We'll see dot head. This will show us first 5. Yes. This won't be any different. Now we will import metrics from sklearn import metrics, and we will calculate the mean absolute error and mean squared error from y test and y prediction. So we will set it as MAE equal to metrics dot mean underscore absolute error y underscore test comma y underscore pred, and then ms y underscore pred, and for mean squared error metrics dot mean underscore squared error, and then similarly y underscore test comma y underscore pred. and we will find the RMSE value, root mean square error, using numpy, square root of mean squared error. Okay, so there was no error, so we can print the values. So say MAE, it is 5.3. Then we can print out MSC, that's 45.88. Then we can check RMSC, which should come to around 7.5 or 6.5. Yes. So so we can take mean from the data. So data dash, and then we can just copy the y title of y. So this is here, unit area, and we can just find the mean. This is 37.98, and then we can check the residuals. So it should be by test minus y bread. And okay, so I can just print it. Test underscore. Yes, so these are the residual values for each column. Then we can plot this. Scatter plot x equal to y underscore test, comma y equal to y underscore comma color equal to yellow, and plt dot h line, and we can set y equal to say 30 for reference, and then color equal to blue, ls, and set it as dashed line. So yes, so we can see this graph. So prediction of prices per unit area, prediction versus test data. And so now we can plot the residuals. So SMS dot this plot test underscore residuals. I can set bins to 25 KDE wanted true, and set color to blue. This should work probably. Yes, so as we can see, we have plotted the disk plot with the axis face grid, and this is how we can use linear regression on a real estate model. So thank you.